For the next few minutes we will discuss spectrum access and licensing. This material provides background for understanding centrally controlled spectrum access and spectrum access systems. In the United States, the radio spectrum is managed by two federal agencies, the Federal Communications Commission, or FCC, and the National Telecommunications and Information Administration, or NTIA. The FCC is primarily responsible for issuing licenses to commercial users, while the NTIA manages spectrum for federal agencies. Radio frequencies are allocated for many uses, including navigation and radio astronomy, in addition to radio and television broadcasting and two-way wireless communications. Demand for the radio spectrum is increasing due to several factors, and the spectrum must be used efficiently to meet this demand. The need for wireless data capacity and spectrum is driven by the growing number of wireless devices, increased use of video over cellular networks, and new applications like the Internet of Things. In many cases, spectrum is used only intermittently by licensed users, so there is an opportunity to use the spectrum more efficiently. One approach to improving efficiency allows licensed users to lease their allocated spectrum to secondary users. Mobile data communication is a major use of the radio spectrum, and this traffic is growing rapidly in all regions of the world. The next few slides are examples of radio spectrum use in time and frequency. In these figures, the horizontal axis represents frequency, while the vertical axis represents power spectral density or amplitude. In the upper plot, a third axis, which can be thought of as extending out of the page or screen, represents time. In this first example, a large part of the radio spectrum shown is being used heavily. A wide range of frequencies are being occupied consistently over time. These continuously occupied frequencies are not good candidates for opportunistic use by secondary users because additional transmissions on these frequencies would cause interference to the current or primary users. The spectral band shown here is used sparsely in time. Although a wide range of frequencies are in use, these frequencies are unoccupied much of the time. In this example, only a small number of frequencies are occupied. Although these frequencies are occupied continuously, many frequencies are available for opportunistic use. The case shown here involves intermittent use of many frequencies. At a given time, some but not all of the frequencies are unoccupied and could potentially be allocated to secondary users. The terms primary user and secondary user are typically used when discussing new approaches to spectrum access. A primary user or incumbent user is licensed to use a portion of the radio spectrum. In some cases, primary users are permitted to lease some of their allocated frequencies to other secondary users. Secondary users must not cause interference to primary users and are generally required to stop transmitting or move to another frequency when a primary user begins transmitting. Various techniques exist to enable secondary and primary users to coexist within a band of radio frequencies. One approach to spectrum sharing is to allow secondary users to transmit on an opportunistic basis in a way that does not interfere with primary users. Spectral holes, or otherwise unused time-frequency combinations, may be used for secondary user transmissions. Overlay, underlay, and interweave are three major ways of achieving opportunistic access. These approaches do not require the secondary users to obtain short-term licenses. Secondary users may have a long-term license that allows them to have secondary access to the spectrum, or may not require a license at all, depending on the specific regulations for the band in which they operate. The overlay approach involves coexistence of secondary user and primary user based on the secondary user's knowledge of primary user characteristics. This may involve cooperation between secondary and primary users. For example, a secondary user could relay a primary user message. The secondary user is responsible for sensing primary user activity. Overlay does not severely limit the power level that a secondary user can use to transmit, which makes overlay well suited to use in large areas. In contrast to overlay, Underlay allows simultaneous transmissions by secondary and primary users. The secondary user's power spectral density is limited to a level that does not interfere with the primary user transmissions. Spread spectrum modulation techniques enable a secondary user to communicate while achieving a low power spectral density. However, due to the relatively low secondary user transmitted power, underlay is most practical for use in small areas. Interweave is a third approach in which secondary users occupy frequencies that are not used by primary users. In contrast to the overlay approach, secondary and primary users do not occupy the same frequencies within a short period of time. There is no coordination between secondary and primary users. Secondary users must sense and avoid primary user transmissions. Interweave does not inherently limit secondary user transmitting power, so it is suitable for use in large areas. Now that we have looked at approaches to opportunistic spectrum access, we can discuss an alternative approach to spectrum sharing that will be the focus of the next exercise. In centrally managed spectrum access, an automated spectrum manager called a Spectrum Access System, or SAS, maintains awareness of current and planned spectrum use and issues spectrum grants to secondary users that request access to spectrum. Secondary users communicate with the SAS using a dedicated control channel, which is separate from channels used for communication among secondary users. A spectrum grant is permission to use a specified frequency at a given location for a specified period of time. The SAS senses the spectrum using dedicated receivers, possibly in combination with crowdsourced spectrum occupancy information from the secondary users. The SAS can order secondary users to vacate frequencies, even those frequencies for which they have spectrum grants, if the SAS determines that a primary user needs to use the frequency. Centrally managed spectrum access has advantages and disadvantages compared to other approaches. Here are some examples of advantages. Use of a SAS that can sense spectrum over a wide area may reduce the probability of interference to primary users compared to adaptation that relies only on the secondary user's own sensing capability. Use of a SAS also reduces required capabilities for spectrum sensing and access in the secondary user radios, which may reduce radio costs. Disadvantages include overhead, that is, some of the radio spectrum is occupied by a control channel that secondary users use to communicate with the SAS. In addition, the SAS may not always be accessible, so secondary user radios may still require their own sensing capabilities. Also, the secondary users may miss the opportunity to use some spectral holes if the SAS assigns frequencies too cautiously in an attempt to prevent interference to primary users. Another approach to spectrum access is short-term licensing, which involves leasing of licensed frequencies to secondary users by the licensed primary user. This approach is not fully opportunistic because it requires secondary users to coordinate with primary users, and also it is distinct from central management of spectrum access because formal licenses are involved, and these licenses typically have much longer durations than the spectrum grants provided by a SAS. This concludes our overview of spectrum sharing approaches. If you are working through the tutorial, there may be some questions to answer following this video before beginning the centrally managed spectrum access exercise.